Hello guys, welcome to the Techogenius Academy. I am your trainer and today we will unravel a new concept. Please like, share and subscribe to the channel and now sit back and enjoy the video.
Hello guys, welcome to the Techogenius Academy. So today we are here to discuss the next topic, part 2 on that kernel timer. So like what we have discussed in earlier video, that how to register kernel timer in Linux driver, and how we can make timer as a priority timer, and we have discussed few of the jiffies at C, like what are jiffies, it's just a counter and all. So we have discussed, we have covered lot of the things. So in this section I just want to explain you the delaying function. So what are delaying functions, when we need to use that? So what is the purpose for that delaying functions and all? How we can use jiffies in a delaying function and all? So we'll go into that. So let's get started. So, in a device, drivers often needs to delay the execution of for a period of time, usually to allow the hardware to perform some tasks. Very short delay typically must be implemented within software loops. So, most of the delay functions discussed here are based on jiffies, which in turn depends on the HC value configured on the system. So first thing is busy waiting. So how we can use busy waiting? By using CPU relax. So if you want to delay execution by a multiple of clock tick, the easiest approach is to loop based on the jiffies counter. Okay, so what CPU relax will do? The call to CPU relax invokes an architecture specific way of saying that you are not doing much with the processor at the moment. Busy loop severely degrades system performance. Okay, so like how we can write this CPU relax? So in a while loop we are using time underscore before, it's just a macro to use the jiffies. So I just want to explain you with the code. So what I will do, I'll just go to terminal. So here I'll just create a directory. Delaying function. Yep. So here we will use busywait.c. This will be better. Yeah. So first I will include some header file. Yeah, hash include linux slash init.h. Hash include linux slash module.h, hash include linux slash kernel.h. For file system we need to include schedule.h. I can use wait here. I need to create the thread. For that I can include kthread. Yes, I need to use delay here. Use delay header file. Device. So we have covered almost the header file. So if we miss something, we'll write it down later. Yep. So what I will do here, I'll just initialize the delay with HZ. Okay. So if you don't know about that HZ and jiffies, please watch out my kernel timer video. That will give you the idea that why we are using jiffies and HZ in the delaying function. So here I need to create one thread. So okay, so I'll create it later. First I'll just start my init module. So init my underscore init, that will be better. Void, yep, print k cond info. We are creating a thread here. This is better. Okay, so now I need to declare the thread globally static struct task underscore struct thread underscore wait, busy wait. Okay, so this looks fine to me. Okay, thread wait equals to, I'm using k thread run. So create is also there. So why we are using k thread underscore run? So I have already created a video on that. So please watch out that. So here I just need to add one function which will go to that particular function when I'll execute k thread run in the init module. Null and the name of the thread. And I can return 0. Okay, so this looks fine to me. And now what I will do, I'll just write also the exit module to my underscore exit. Oop, yes. Print k removing the module con info we can use here. Okay, so now if thread weight is not equals to null, k thread stop thread wait, print k con info stopping the thread. So this looks fine to me. I just need to create initializer for that. This macros will call my init and exit module. Yeah, this looks fine to me. I'll just write the license over here. Module license GPL. Author Techogenius Academy. And the description. So you can see these all details by using mode info. So if you want to try it, please try that in when you are practicing these codes. busy wait, sample code. Great. So this looks fine to me. So now I need to create the function, thread function. Yeah. So thread function we can write here. Void star anything. Wait. Yep. So now I'll just declare too long here. jiff1, jiff2. Okay, so G1, G2. This will be easy because I need to use jiffies too. So J1 equals to jiffies is just a counter when it starts, when the system boots. J2 equals to J1 plus the delay. Okay. So now while time before first long we need to pass jiffies and other one is J2 up to that value. Yep. So now what we'll do, we will just relax over here up to this time, like when the jiffies, when the system boots up to that jiffies value which we have put the delay over here, up to that till we are making CPU relax. After that we will put the jiffies value, whatever the jiffies value is there, we'll put into J2. Okay, so now what we can do now, okay, we can print here the values. Jiffies starts equals to percentage lu slash t and jiffies ends at percentage lu slash n j1 comma j2. Okay, so now here we can write like if any signal is panting currently, then break that and come out from that loop. So now we need to allow the signals to. So what we can do here, we'll just write the allow signal kill or anything if we need to kill, if we need to delete this process. Okay, so now here I can put all these things in a loop, in a thread, so I can use k thread should stop, and that k thread should stop. So k thread should stop, what it will do, just check it out my previous video so you can have that idea. Yeah, yeah, this looks fine to me. Okay, so for better understanding I can just print some log here. Thread stop is stopped. Okay, and we make to do this thread underscore weight equals to null. Yep, and we can exit also from here. Yeah, so this looks fine to me. So I've just created the thread function, and in this I'm using time underscore before jiffies macro, just to put my CPU relax for some time. Okay, so now what I can do here, for make file I can just copy my make file to the link function. Yep, pc underscore weight. Yep, pc underscore weight. So this looks fine to me. Yep, make. Okay, so allow signal and signal pending. Okay, so this is the error. Maybe like I have updated my kernel, so that's why it's giving me this error. So what I can do here, hash include my Linux version dot h, hash if Linux underscore version underscore code is greater than equals to my kernel version. 4 series I'm using. Yep, then include my Linux schedule signaling header file, signal header file, hash and if. Okay, so this looks fine to me. Yep. So what I can do here, I can just delete the logs. Yep. Yeah. So now I can just insert my code here, the message. Yeah. So now Jiffy starts at like I'll just spell this 246, the last three digit of that number, and ends at 496. So now the next starts at that 496 and ends at the 746. So you can see here that at this time, like Jiffy start, and it is CPU is relaxed at that time, and also in this way you can use this CPU relax and the time before macro, like how you can do the delaying function and all. So if we can go through this, the one problem in this, like if the kernel is configured with the preemption disabled, means it is that will not go to that some other CPU, that will not acquire the other CPU. The loop completely locks that processor for the duration of the delay. Okay. One other thing is there, if interrupt happens to be disabled, like so if other interrupt cannot be entered into that, so what will happen? So when you enter that loop, so CPU relax, so the jiffies won't be updated. Okay, so the jiffies will not be updated. Why? Because this while condition remains true forever, means like if I'll just go to some this code. So if you can see this, so if we disable the interrupt over here, what it will do, it will enter into this loop and it will be the CPU will be relaxed forever. So in this, the system degrades, or it will go into some deadlock, or this will happen. So in place of CPU relax function, we might explicitly release the CPU when we are not interested in it. So there in a busy waiting. So if we don't need our CPUs to be relaxed and all, if we want to go out, so how we can release that? The function which we can use is schedule. So schedule function can be used to explicitly release the CPU. Okay, so the current process does nothing, but it is running in the it remains in the run queue. Okay, so now how we can do that? Uh, I can. Okay, so I'll just keep this code as it is. I'll just uh, copy my busy way to schedule.c. So this looks like what I need to change here. I will just change this CPU relax to schedule. So everything will remain same here. So now here we can hit schedule sample code. Okay, so I need to change the makefile to pj-m plus equals to schedule.o. Make, okay, the message -c, inserting the module schedule.ko. D message. So the jiffy starts 912 and ends at 162, and then again it starts at 162 and ends at 412, and it keeps on doing that. So I can just remove this. Yeah, stopping the thread. So what it means, like if you it is schedule is explicitly releasing the cpu, but that if the system gets busy, the driver could end up waiting longer than expected. So, like if the best way to implement delay, because this is like we are putting a system into the delay just to do our work or whatever it is. So in a kernel, like we are doing this. So best way to implement delay is usually to ask the kernel to do it for you. Actually, there are two ways of setting up the jiffies based on timeout values, depending on whether your driver is waiting for other events or not. It depends on that. So if the driver is waiting for the events, use wait queues, and if the driver is not waiting for the events, just use schedule line timeout. So if your driver using a wait queue to wait for some other events, but you also want to be sure that it runs within a certain period of time, it can use wait event timeout or interrupt timeout and all. So these functions sleeps on the given wait queue, but they return the amount of timeout expires. And that if the timeout expires, the function returns 0, and if the process is awakened by another event, it returns the remaining delay expressed in the gphase. Okay, so there are some calls like wait q underscore had wait underscore event underscore interruptible underscore timeout, and if we if our driver is not waiting for some event, and we can use schedule underscore timeout, where timeout is the number of jiffies to delay, and the return value is 0 unless the function returns before the given timeout has elapsed. Okay, so for better understanding, what I can do here, uh, for scheduling the timeout here, uh, I can copy. Okay, make clean. So what you can do here, copy schedule underscore timeout dot c vi schedule underscore timeout dot c. So in this line schedule underscore timeout, what you can write here, schedule underscore timeout. Okay, you can put here, and you need to pass actually what is that parameter. So the timeout value you need to pass here, so you can pass delay here, and this time before you don't need to mention it here. Okay, so what I can do here, okay, let's show. Yeah, so I can just set the state here, that will be better. Set current state task interruptible. Okay, so this we don't need because we are putting it here, scheduling timeout. Yeah, and there is no need of because we have already setting the states and all, so there is no need of this. So this looks fine to me. what I can do here is correct. Okay, so this looks fine to me. Make file obj-m plus equals to schedule underscore timeout dot o. Make, oops, there's so many errors. I just need to check. Yep, this looks fine to me. Inserting the module, the message. So you can see this delaying function execution or creating the thread. So in this way you can use these calls and all. Yep. So now the other thing is wait Q. Wait Q, how you can do that? So you can use the wait underscore event interruptible also, and the wait Q underscore head too. So okay, what I will do again, I'll just copy schedule underscore timeout to wait Q. Event interruptible dot c. Okay, this, okay, I need to change some stuff here. So now I need to use, I need to declare here wait Q head, wait underscore Q head underscore T and WQ underscore head. Okay, so this looks fine to me. After that I need to initialize the wait Q, wait Q head, and we need to pass here, I just need to check, okay, address of the wait Q head. Yep, and in this current state, what I can do here, I can use my call wait underscore event interruptible timeout. First parameter is wait Q head, okay, and 0, and after that delay. Okay, so now wait underscore event underscore interruptible then interruptible timeout. Yeah, wait Q head comma 0 comma delay. Yeah, so schedule timeout, we'll just remove this. Okay, So this looks fine to me. I can just change the weight Q here. Weight Q event interruptible. Sample code. Yep. Oh, sorry. I just need to include in the make file too. obj-m plus equals to weight Q event. What I have mentioned. Event. Okay. So this looks fine to me. Yep. Awesome. I can just remove some comments here. Some log weight Q KO T message. See. So here also you can use the weight Q event as a delaying function. And this will be used like if your driver is waiting for some events to complete. Okay, if it's not waiting, you need to use schedule underscore timeout. So in this way you can use the delaying function. So there are like different methods I have showed you. There are also other calls which like the kernel provides for the short delays also, which is like n delay, u delay, m delay and all. So you can use m sleep, I think so. There are some kernel calls also, so for that. So my opinion is you to just try it in your system, and if possible try to use this short delays or sleep calls also. That will give you the better understanding, and try to match it with some interrupts. Try to include it into your Linux drivers and all these things, so how you can practice it, you can learn more and all. So hope you like this video and all, hope you like this all session. So next what we will do here, we will further go into some, actually I just want to explain you some atomic operations and all, some weight queues and all, and then we will go to some interrupt handling, because actually I missed mutex and the work queues. So we have discussed tasklets and how we can use spin locks in the tasklets and all. So few concepts are pending in the Linux device driver. So I'll try to cover as much as I can. I'll show you the code and all. And few of you told me that we want code and all. Actually, why I'm not giving you code, because if I'll give you the code, so you'll just copy paste and you will run in your terminal and you'll just go. So in that way you can't understand what these calls are doing. And also if you're writing by there, you're on that will give you the better way of understanding in depth and all. So if if you want, then what I will do, I will just create one session, one video on GitHub. So I'll just push my code on the GitHub, so you can take it from there. And so yeah, thank you so much. Hope you like this video. Please don't forget to like, share and subscribe. Your subscription matters to this to grow the channel, and I'll try my best. And our team is currently working on that concepts and all, so we will give you the most of the content in the Linux device driver. And please mention like what are the other topics you want. So I'll try to make videos, some sessions with some PPTs on that. Okay, so thank